When the Pentagon formally unveiled its latest flying-wing strategic bomber, the world's attention was drawn to its sleek silhouette and enhanced ability to evade enemy radar. However, within the military intelligence and defense analysis community, this aircraft's true leap forward isn't a superhuman bomb or an experimental laser. Its most destructive secret weapon is an open systems digital architecture that transforms it into an invisible electronic warfare node, an airborne cyber command center. This revolutionary aerial platform was designed from its inception to break the traditional mold of combat aviation. The aircraft should no longer be understood simply as a long-range flying truck, whose sole mission is to transport tons of conventional or nuclear explosives deep into enemy territory. The true competitive advantage that puts it decades ahead of any global competitor is its ability to act as a distributed command center in deeply hostile and heavily guarded airspace. If you're passionate about cutting-edge military technology, the secrets of aerospace intelligence, and the new digital weapons that are changing the face of modern combat, subscribe to the channel now and turn on notifications so you don't miss a single episode. The most devastating difference between this new model and bombers developed in past decades lies not in the thickness of its fuselage or the speed of its engines, but in the very structure of its computer code and hardware. In military projects of the last century, updating the flight program or installing a new sensor on an aircraft required bureaucratic processes that took years, multi-million-dollar contracts with the original manufacturer, and months of physical testing in specialized workshops to certify that the software would not conflict with the aircraft's controls. The implementation of the modular architecture of open systems breaks the cycle of slowness and industrial dependence. This technology allows Air Force engineers to integrate new software, state-of-the-art sensors, or artificial intelligence algorithms in a matter of days or weeks. The process is as simple and fast as installing a new app on a modern mobile phone, giving the aircraft almost complete immunity to technological obsolescence. If a rival power develops a new variable frequency radar or deploys a novel electromagnetic interference system on its borders, the crew of this bomber doesn't need to wait years for a workshop modification. The aircraft can receive an electronic warfare software patch specifically designed to neutralize that new threat just hours before takeoff for its next mission. This near-instantaneous adaptability ensures that the bomber always remains one step ahead of any existing defensive network on the planet. This unprecedented computing flexibility transforms the platform into a deadly weapon capable of penetrating the densest and most sophisticated air defense belts on the planet. The integrated long-range missile networks developed by rival powers rely on high-powered radars to scan the skies and guide their projectiles. Instead of simply flying under radar to launch missiles and quickly escape the area, the new bomber performs an undeclared active and passive electronic warfare role from deep within enemy territory. Through its advanced suite of high-precision sensors distributed throughout the fuselage, the aircraft continuously tracks the exact location of all electromagnetic emissions from ground-based radars. Once the emission sources are identified, the onboard system can launch targeted cyber attacks or emit highly precise jamming signals to blind enemy missile batteries. This entire digital neutralization process is carried out without revealing the bomber's physical position on the adversary's radar screens. Simultaneously, the aircraft operates in complete electromagnetic silence to remain an invisible data node in the middle of the night. Instead of emitting powerful radar signals that could betray its presence to enemy receivers, the aircraft acts as a passive receiver, absorbing information from its surroundings. All the intelligence gathered on the position of ground defenses is immediately processed by its computers and redistributed to other allied platforms operating on the periphery of the conflict zone. This massive transfer of tactical data is carried out via directional links with a very low probability of interception. The aircraft can project ultra-narrow data beams toward fifth-generation fighters, warships at sea, or ground command stations in a manner virtually undetectable to enemy listening systems. Thanks to this constant flow of information, the bomber acts as the invisible eyes of the entire joint force. allowing other platforms to fire their weapons from safe distances at targets designated by the aircraft at the front. The strategic outcome of this doctrine is the complete transformation of hostile airspace. The missile battery attempting to ambush Allied aircraft is suddenly blinded by electronic jamming and locked onto the attack screens of fighters flying hundreds of kilometers away. The bomber's ability to dismantle the enemy's digital architecture before they can react demonstrates that electromagnetic invisibility is not merely about not being seen, but about dominating and silencing the spectrum through which the adversary's information travels. In addition to the power of its computer center and its dominance of the electromagnetic spectrum, it boasts another doctrinal advancement designed from the very blueprint stage: native integration with collaborative unmanned systems. Unlike previous aerial platforms, which had to be modified haphazardly over the years to attempt communication with robotic aircraft, this strategic bomber was conceived from day one to command veritable swarms of autonomous drones in the heat of battle. From its spacious digital command bay, the crew or the aircraft's own computer systems can simultaneously coordinate the deployment of small unmanned aerial vehicles, UAVs, flying ahead of its flight path. These low-cost robotic companions venture into the most dangerous airspace to perform three critical missions that ensure the mothership's survival. First, they function as active decoys programmed to emit massive electromagnetic signatures that mimic the position of large aircraft, forcing enemy batteries to activate their radars and reveal their exact locations. The second critical task of this support swarm is the real-time mapping of mobile ground defenses. Small drones fly at low altitudes to locate missile launchers concealed beneath tree canopies or behind geographical features, immediately transmitting the coordinates to the bomber for swift destruction. Finally, these autonomous units operate as strategic communications repeaters, weaving an airborne data network that keeps tactical radio and internet signals completely stable in environments where rival powers attempt to jam frequencies with powerful interference equipment. Alongside swarm control, the bomber's computer infrastructure holds an even more ambitious design secret for the most dangerous missions. Although the first units to enter operational service carry a human crew on board to oversee complex operations, the flight system architecture was built with the native capability of being operated remotely or fully autonomously using advanced artificial intelligence algorithms. This optionally manned flight capability allows strategic commanders to consider combat scenarios that were previously unacceptable due to the risk of loss of life. In deep penetration missions over territories protected by dense missile networks or in environments contaminated by chemical or nuclear weapons, the bomber can be deployed solo without a single pilot in the cockpit. The aircraft is capable of taking off, navigating evasive routes, coordinating its swarm of drones, executing the strategic strike, and returning to its home base completely autonomously, forever redefining the limits of risk in modern military aviation. The combination of a modular software architecture, passive electronic attack capabilities, native integration of robotic swarms, and optionally autonomous piloting marks a definitive turning point in the history of military aviation. This new bomber demonstrates that the race for strategic air supremacy is no longer measured by the amount of explosives carried or the top speed of the turbines. True deterrent power on the global geopolitical stage now lies in the ability to process data, dominate the electromagnetic spectrum, and impose absolute cyber control over the enemy. By transforming a single platform into an invisible command center capable of coordinating the combat effort of fighters, ships, satellites, and drones in real time, the effectiveness of traditional defensive networks is nullified. The multi-billion-dollar investments made by rival powers in long-range missile batteries and high-powered radars risk becoming obsolete against an adversary that doesn't need to destroy physical installations to render them completely inoperable. The ability to blind an adversary's sensors and rewrite onboard software mid-mission permanently changes the game. This technological leap also reshapes the economic balance of nuclear and conventional deterrence. Building and maintaining a fleet of bombers capable of being updated via instant software patches is infinitely more cost-effective than designing new aircraft from scratch each time the enemy develops a defensive advantage. The open systems architecture ensures that aircraft performance evolves at the same pace as the microprocessor and artificial intelligence industries, extending their service life for decades without losing their strategic edge on the front lines. The message conveyed by the deployment of this jewel of military engineering is clear to all strategic commands on the planet. The aviation of the future will not belong to the nations that build the largest or heaviest aircraft, but to those that manage to weave the most resilient, flexible, and intelligent digital network. Domination of the skies is no longer decided solely in the air, but in the lines of code that allow machines to think, adapt, and prevail amidst the electromagnetic fog of modern combat. With this platform in the air warfare doctrine enters a new era where information is the ultimate weapon. The ability to penetrate any defense undetected, silently coordinate robotic armies, and neutralize threats with the precision of a software patch ensures that strategic deterrence remains steadfast in the face of tomorrow's challenges. This superiority is not based on brute force, but on a perfect symbiosis between electromagnetic invisibility and absolute cyber command. By dominating the spectrum where the enemy attempts to communicate and see, the bomber not only survives but redefines the operational environment in its favor, rendering the rival's defensive infrastructure a network of useless and isolated sensors. In this new paradigm, the aircraft ceases to be an isolated unit and becomes the epicenter of an intelligent combat ecosystem, capable of learning and adapting in milliseconds. True modern military mastery, therefore, consists of dominating the invisible mind that directs the battle before the first projectile is fired, ensuring that control of the skies is a direct extension of mastery over information and code. If you were amazed to discover the true digital secret hidden within the world's most advanced bomber, subscribe to the channel immediately, like this content, and share it with your military strategy enthusiast friends to continue exploring the secrets of future firepower together.